So yeah, probability of A plus the probability of not B, and then minus the probability of A and not B. So what do A and not B have in common? Well, they have this, 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 and this, because none of these have 3s, so that would be 4 out of 36. So minus 4 out of 36. Again, this is 6 plus 25 would make 31. Minus 4 is 27 out of 36. 30 says, suppose at a high school 263 students study French or Spanish. The school reports 98 students study French and 194 study Spanish. How many students study both languages? So it might be good to have a Venn diagram for this one. So here's French, here's Spanish. So this intersection right here, we could find, we know that the number of students who study French or Spanish needs to be the number of students that study French plus the number of students that study Spanish minus the number of students that study both. So French or Spanish or both is 263. 98 students study French. So that's 98. 194 study Spanish, and then we can subtract off the number that are studying both. So if we use our calculator for that, we get 263 minus 98 minus 94, which is negative 29. So we should get 29 equals the number that are studying both French and Spanish. So this is 29. So then the remaining that study Spanish is 194 minus 29, which is 165, and the remaining that study French are 98 minus 29, which is 69. So how many students study both languages? 29. Then it says, if one of the 263 students is chosen at random, what is the probability that the student is not studying both languages? Well, just find the number of students that are not studying both languages. That's 165 plus 69, which is 234, and divide by the total number of students, 263. 31 says, if M and N are complementary events, find the probability of M or N or both. But if they're complementary, then that means that this needs to be 1. There's a 100% chance that you'll choose one or the other because they're complementary events. All right, 32, nice binomial probability. Kevin Durant makes 90.5% of his free throws. If he takes 20 shots, what is the probability that he will make all of the shots? Well, that's simply 0.905 to the 20th power. There's a 90.905 chance that he makes the first one, and you simply multiply all of those because they're theoretically independent, even though probably whether he makes it or not affects his confidence. Miss all the shots would simply be let's see, what would that be? 0.095. That's 9.5% that he misses them to the 20th. Miss exactly 2 would be 0.095 squared times 0.905 to the 18th. But this only counts one way to organize them. This would be like missing the first 2, or missing the last 2, or missing the middle 2. And so we need to count up all the ways there are to miss 2 shots. You could miss the first 2, the last 2, the middle 2, the first and the third, etc. And the way to do that is 20 choose 2. That's the number of ways. So we need to multiply that by 20 choose 2. That comes from the binomial theorem. Miss the second shot and the 5th shot only. That is just one way to miss 2 shots. So that's just simply 0.095 squared times 0.905 to the 18th. Miss at most 3 shots. Well, that means you can miss none, 1, 2, or 3. So missing none would be 0.905 to the 20th. Missing 1 would be 20 choose 1 times 0.095 times 0.905 to the 19th. Missing 2, we already did. 20 choose 2 times 0.095 squared times 0.905 to the 18th. And finally, missing 3. 20 choose 3, 0.095 cubed, 0.905 to the 17th. If you add those up, you will get the probability that he misses at most 3 shots. Finally, 33 says, a weighted die is rolled and the results are shown in the table. We'll define the rolling events 1, 3, and 5 to be A, 2, 3, or 4 to be B, 1, 3, or 6 to be C. Calculate the following probabilities. So, the probability of A given C is the probability of A and C divided by the probability of C. So A and C, well, the probability of A and C, well, the things they have in common are 1 and 3. So the probability of getting a 1 or a 3 is 0.1 plus 0.3. That would be 0.4. Probability of getting C is if you get a 1, a 3, a 6. So that's 0.1 plus 0.3 plus 0.04. That's 0.44. So whatever that quotient is probability of A given C. And you can do the same thing for the probability of C given A. We'll look at this one as well. The probability of B given C would be the probability of B and C divided by the probability of C. We already found the probability of C to be 0.44. Probability of B and C, well, what do they have in common? They have the 3 in common. So the probability of getting a 3 is only 0.3. So whatever that quotient is would be the probability of B given C. To determine whether B and C are independent, we need to see if the probability of B times the probability of C is equal to the probability of B and C. So the probability of B, 2, 3, 4, would be 0.5 plus 0.3 plus 0.05, which is 0.85. Probability of C, 1, 3, or 6, would be 0.1 plus 0.3 plus 0.04, which is 0.44. And the probability of B and C we found to be 0.3. So we're wondering if this is true. It's not. 0.85 times 0.44 is 0.374. And that does not equal 0.3. So they are not independent. Okay.